In this example, we want to solve the following exponential equation. 32 raised to the x power is equal to 16 raised to the x plus 1. On the left side, notice that the base is 32, and on the right side, the base is 16. So the bases are not the same. And our goal is to get the bases to be the same. We want to get common bases. So I'm going to start on the left side by rewriting 32. I know that 32 is the same as 2 to the 5th power. So I'm rewriting 32 as 2 to the 5th. And then, of course, that is still all getting raised to the x power because we originally had 32 raised to the x power. So notice I haven't changed the problem. This is equivalent to what I had in the beginning. So now I'm going to do the same thing on the right-hand side, and I am going to rewrite 16. But notice I have chosen a base of 2 here on the left side, so I'd also like to choose, if possible, a base of 2 on the right side. Well, luckily, 16 is 2 to the 4th power. So I'm rewriting 16 as 2 to the 4th, and then, of course, that is all being raised to the x plus 1 power. So now remember, when you have a power raised to another power, we're going to multiply our exponents. So a power raised to a power. 5 times x is just 5x. And then we have to multiply 4 times the quantity x plus 1. So don't forget to distribute there. That'll be 2 raised to the 4x plus 4 power. Now you have a base of 2 on the left as well as a base of 2 on the right. And when the bases are the same, we know that the exponents will be equal. Sometimes that is called the uniqueness property. Sometimes they call that the equivalence property. But as long as you have common bases, the same base on the left and the same base on the right, then you can set your exponents equal to one another and continue solving. So if you just subtract 4x, you'll end up with x is equal to 4. So our solution set, if you want to write it as a solution set with curly brackets, would be just the number 4.